8-3 in Advanced Algebra 1. So far we have been factoring quadratics. Here is the generic formula for a quadratic equation, which I guess it's just an expression in this case, but they can also be equations. But here's the weirdest part. Like, we're letting the variable be x. And are you cool that it's got like x's and x squareds in it? The weird part for students is these a, b's, and c's. The a, b's, and c's are just numbers. So like, let's start with this guy right here. Like, a is the number in front of x squared. Could you tell me what number is in front of x squared? It is a 1. Are you cool with that? B is the number in front of x. How do you feel about him being 13? And C is just called the constant term because he doesn't have a variable with him. He is 22 in this case, right? So last time we did perfect square trinomials, and the time before that we did difference of squares, and then we even did GCFs. Today, I won't lie to you, I made up this phrase. It's called easy factoring. The reason why I made up easy factoring is because it is easy to do. But first, let's dial into this. Can I take a GCF out of that? Is there a greatest common factor to any of these guys? X was shouted out. This has x's with it. This has x's with it. Does that have any x's with it? So good try. Can't quite take out an x, right? So what about a number? This is 22. This is 13. This is 1. Can we factor out any kind of number? Besides 1, you can always factor. So there is no GCF. The next thing I would see is this a difference of squares? I don't know if we talked about it last time. I know the other class did. Difference of squares looks like this. Isn't that thing like a difference of squares? How many terms do you see in this guy? 2 terms or 3 terms? Just 2. It's got to have subtraction. Doesn't that have 3 terms with it? Are you with me on that? So difference of squares isn't going to fit. Maybe it's a perfect square trinomial. Is the first term a perfect square? Yes, it is. Is the last term a perfect square? 22? So that's kind of crappy. So we're on to the most popular type of factoring, is easy factoring. And here's the thing. You can only do it if the a value is 1. And are we cool that the a value in this expression is 1? And here it is. If you have had this class in 2024/2025, the last question on homework has asked you repeatedly, can you find 2 numbers that multiply together to be this and add together to be that, right? That's where I'm hoping this pays off today. Here's our job. To easy factor, we need to find 2 numbers that multiply together to be C. Are you cool? In this case, that C is 22, right? Here's what I also want to dive into. We haven't yet talked about it. I would like to know what you think about the signs of those 2 numbers. Like, should the 2 numbers that I find both be positive, both be negative, or one of them's positive and one of them's negative? They have to multiply together to be 22. Discuss. Here's where they can't be, one of them positive and one of them negative. Are you with me on that? Because doesn't a positive times a negative turn out to be a negative in that case? So they could both be positive, or they could both be negative. So we already kind of have something down with the signs, but here's what they have to add together to be. They have to add together to be 13, right? They have to add together to be that. So what I like to do is make a little list, and you'll notice that I'm a math guy. I go in numerical order. I start with 1. Why don't we write this down with me? 1 times what would give me 22? 1 and 22. Do those numbers add together to be 13, though? Nope. So I cross them out, and I go to the next number on my list, 2. 2. Does 2 even go into 22? 2 times what? 11. Do those 2 numbers add together to be 13 also? Bingo, right? There's our bingo numbers. And watch how easy this is to factor. You put yourself 2 parentheses times each other. Whatever letter they're dealing with, like in this case it's x's. I know some of them are squared, right? But they're dealing with x's. That will lead off each parenthesis. And then the 2 numbers you found, this is a positive 2, right? So I'm going to put a plus 2. And this is a positive 11, so I'm going to put a plus 11. That's it. That is that guy factored. 100% done. You know what I just did? You remember we used to call this FOIL, but I didn't really make you call it FOIL. If I was to multiply these guys out, I'm going to get what I started back. So you don't need to write this down, but I'm going to do it. Let's like distribute like what we did last chapter. You know how we're going backwards? So x times x is x squared. X times 11 is 11x. Then I got to cross that guy out and go to this. 2 times x is 2x, and 2 times 11 is 22. There's some like terms right there. What did those add together to be? Isn't that like basically unfoiled in this case, or unmultiplied out? You know, this whole chapter is going backwards, so we just took it from standard form and put it in factored form. And how do you do it? Find 2 numbers that multiply together to be c and add together to be b. But it only works if the a value is 1. Who's the a value? The number in front of the squared guy is the a value, which is really weird on this guy, 1. What do you think? So here's our job. Find 2 numbers that multiply together to be that. Time out. Let's figure out their signs. Should they both be positive, both be negative, or one be negative? If they have to multiply out to be negative 14. One of them is negative, right? One of them is negative. What do they have to add together to be? Negative 5. Are you with me on that? Negative 5. So if I was to start fresh, like you haven't been practicing this all year, you know, I would do this. I would do 1 and 14, but one of them has to be negative. My bad. But one of them has to be negative. Would you believe there's 2 different combinations of that? You know, it's like either the 1's negative or the 14's. Do either one of those add up to be negative 5? What do you think? Yes or no? I'm not going to make you write this list down either. It's not forced upon you. But you'll see as the numbers get larger, the list is helpful. So then I go to 2. 2 and 7, but one of them has to be negative. Are you with me on that? Do any of those combinations add up to be negative 5? Top one or bottom one? Bottom one. So this will factor to be a plus 2 times a minus 7. How did I know which one was which? Wasn't the 2 positive? Are you with me on that? And the 7 was negative in that case. Why am I not solving these guys either? Why am I not solving? Not equations, right? They are not equations. So we just unmultiplied this guy out, which is called factoring it. We're doing the reverse. So let's rock it again. Is the a value 1 on this guy? The first term's like coefficient. Find 2 numbers that multiply together to be negative 12. What's their signs? Both positive, both negative, or one negative? One of them's negative. And they have to add together to be positive 4. Ready? Break. But they both, one of them has to be negative. So 1 and 12, if one of those was negative, that's not going to work. 2 and 6, right? If one of those was negative, that is going to work, isn't it? This combo right here. Don't those add together to be a positive 4 in this case? So how does it factor? Into 2 parentheses times each other. X was the letter, so it'll lead off each parenthesis. One of them is a minus 2, one of them is a plus 6. What if I wrote it like this? Is this the same thing or different? Are those 2 the same or are they different? They're the same. It doesn't matter if the plus 6 comes first or the plus 6 comes last. It does have to be a plus 6, and the other one has to be a minus 2. Are we okay with that? Cool. So this is called easy factor, and I made that up because when we do next time's lesson, you'll be like, yep, that last time was way easier than this, right? This is easy factor. And when does it work? When the a value is 1. Let's see if we can find 2 numbers that multiply together to be 10 and add together to be 7, right? There are signs, both positive, right? What do you think? What are our 2 numbers? 2 and 5, right? So I personally think you'll find an advantage to write them off to the side. You know, when you find the 2 numbers, if you don't need to make a list, I don't care. But when you find the 2 numbers, put them right here. I call those our bingo numbers. Bingo! These are the ones that are going to work, right? So then we will factor this guy to be t plus 2 times t plus 5 in this case. Awesome sauce. I would like to change the next one due to the fact that I see some. Never mind. Let's go ahead and do the next one. You tell me, why easy factor? Tell your neighbor, why easy factor? The answer is because the a value of this quadratic expression is how much? 1. That's the only time we get to do it, right? If the a value is 1. So we're trying to find 2 numbers that multiply together to be negative 24. Think about their signs. Both positive, both negative, or one negative. If they have to multiply together to be a negative 24. You tell me. 1 negative, work on it. Work on it. Negative 8 and 3. Cool. I don't know if this is a good thing or a bad thing because you've been practicing it. Like I said, you guys have been practicing this all year long. They said negative 8 and 3. My math brain can't compute that very well. I like 3 and negative 8. Do you know why? Because I like the smaller number to come first when I'm thinking about them as positives. You know, the smaller number to come first and the bigger number to come second. But it's not wrong if you had negative 8 and 3. Does that make sense? But when we start frowny face factoring, you might be like, yeah, maybe that smaller number first and that bigger number second is a good idea. Okay? Today's easy factor. Next time it's frowny face factoring. Guess why? It's a lot of work, right? It's a lot of work, right? So, all right, let's do it. X plus 3 times x minus 8. All right, this is the one I've been waiting on, number 6. What do I got to find the two numbers to multiply together to be? They have to multiply together to be what? 4, and have to add together to be negative 4. Find those two numbers. It's not the longest list in the world you'd have to make because there's only two sets of numbers that multiply together before. It's like 1 and 4 and 2 and 2. Are you with me on that? But none of those add up to be negative 4. Why do none of those? The first one adds up to be 5. The second one adds up to be positive 4. What needs to be true about both of these numbers if they multiply together to be a positive, but add together to be a negative? They both have to be what? Negative. So both negative. And there's your bingo right there, isn't it? Negative 2 and negative 2. Are you with me on that? Ooh, not only was I waiting for that, look at this. B minus 2 times B minus 2. Is there a fancier, schmancier way to write that as opposed to B minus 2 times B minus 2? How could I write that? B minus 2, what? Squared. Oh, Monday morning. Could you tell me what that means that guy is? I will let you guys try number 7. Sorry that I cut that off, but that was a perfect square trinomial is what that guy was. A perfect square trinomial. Why easy factor, though? Why easy factor? Even for a beginner, once they understand you're trying to find two numbers that multiply together to be that, when that number is 3, bro, you only got one option. It's 1 and 3. Are you with me on that? I take that back. It could be negative 1 and negative 3 also, but I have to look to what they need to add together to be. If they had to add together to be a positive, would you believe I have to have both signs be positive in that case? So isn't it just 1 and 3, right? So 1 and 3, so that would be x plus 1 times x plus 3. And I'll put my bingo numbers right there. Cool? All of those were easy factorable. Talk to your neighbor about number 8. Is number 8 easy factorable? Y'all shook your head no. Why not? Your A value is not 1. Isn't the A value 2? So let's talk ourselves through the factoring cheat sheet. This is a test question, by the way. It'll be the last couple of questions on your homework today. It's like, what option of factoring would you choose? And then we'll start drawing the factoring cheat sheet here maybe next time. First thing on there, GCF. Discuss with a neighbor. Is there a GCF you could take out? What do you think? 2. Let's factor it out. So the 2 does not disappear. Can't take an m out because m is not in the third term, right? You know, but I can definitely take a 2 out. What would this first guy turn out to be? M squared. Yes. Plus 7m. Nice. Plus 10. Cool. We took a GCF out. Now look at that green thing. Only focus on the green thing. What's the A value? 1. Are you with me on that? Isn't the number in front of m squared now 1? So I got options. Maybe that green thing is a difference of squares. It cannot be a difference of squares because it has 3 terms, right? Maybe it is a perfect square trinomial. Is m squared a perfect square? Yes, it is. Is 10 a perfect square? No, it is not. So the only thing left I got is maybe this is easy factorable. The A value is 1, right? Can you find two numbers that multiply together to be 10 and add together to be 7? Discuss that. Like I said, this is new to me that we've been practicing this all year. So what are those two numbers? 2 and 5. We'll put our bingo numbers up here, right? 2 and 5. But here's the thing, Mr. Blue 2 doesn't get to disappear. But this one big parenthesis turns into the two parentheses times each other in that case, to where it would be m plus 2 and m plus 5. Weird. Took out a GCF. So there's one more of these left. Do you see that the A value is not 1, right? That is first case scenario. It's like, yo, bro, I probably need to take out a GCF. So what do you think on number 9? What could we take out for a GCF? 3. 3. And then look inside those parentheses to see if 1, that could be a perfect square trinomial, or 2, is it easy factorable? Like R squared is a perfect square, but 2 is not a perfect square, right? So that's not going to happen. So I need to find two numbers that multiply together to be positive 2, but add together to be a negative 3. Think about those signs. Shouldn't they both be negative, right? And how do you feel about a negative 1 and a negative 2? What do you think? Am I lying about why I call this easy factoring? And think about it. You have been training for about 5 months on how to do this, you know. So this should be extremely easy factoring. Why didn't we solve any of those? Didn't have an equal sign. Do these have equal signs? Yes. If we're going to easy factor, we want to get it ready to run, which is equal to 0 first. If it's a perfect square trinomial, we don't need that to happen. So let's talk about number 10. First, since there's 3 terms, first look, is there a GCF? Is there a GCF you can take out? Nope. Is it a perfect square trinomial? Like usually the first guy is kind of a giveaway. Sorry, the first guy's kind of a giveaway. You're looking at that guy. Is he a perfect square? You know, so he is not. So this is going to be easy factorable, hopefully. Got to have it equal to 0 first. So our job, find two numbers that multiply together to be a positive 3 and add together to be a negative 4. And see if your bingo numbers match my bingo numbers, right? Then we just factor that left side. It'll be x minus 1 times x minus 3, but the equals 0 comes down for the ride, right? Comes down for the ride. So then we got to go back to a couple of times ago where we used that 0 product property. Don't we have two dudes times each other, like equal in 0 in this case? So either pink guy, sorry, hitting every wrong button possible today. Either pink guy could be 0 or blue guy could be 0. So what value of x makes the pink guy 0 if x equals? What minus 1 is 0? 1, right? Or what value of x would make the blue guy 0 if x was 3? There's our two answers in that case. Pretty neat. Let's try that again. Let's see if this is a perfect square trinomial. That's a perfect square, and that's a perfect square. So if I did a y minus a 2, is this guy right here twice the product of those square roots? Multiply those together, you get negative 2y. Double them, I should get negative 4y. Did I get that back in the middle? So that is not a perfect square trinomial. So he's going to have to probably be easy factor it. I need to stress this. Why is it easy factoring? Because the a value is how much? 1, right? So can we find our two numbers? It's got to be ready to run, like equal to 0, which it is. So got to multiply together to be positive 4 and add together to be a negative 5. So that's negative 1 and negative 4. So y minus 1 times y minus 4 equals 0. This is called the factored equation. Homework will probably have you do that. It's like write the equation in factored form. That's the two parentheses times each other. Then solve for y with the 0 product property. Y could equal 1 or 4. Cool. Try number 12 with a neighbor. We went through it all. This is an easy. factor because this is once not a perfect square trinomial, even though that's a perfect square and that's a perfect square. Like, you need to get 6m back in the middle for that to be a perfect square trinomial, so it didn't work. So who are our two numbers that multiply together to be 9 and add together to be 10? 1 and 9. You know, it's pretty obvious, right? So m plus 1 times m plus 9 equals 0. M could equal -1 or -9. That was the three basics right there. Those were all ready to run and nice, easy factorable. Number 13, the a value is definitely 1. Why is this not in good shape, though, to easy factor? Not equal to 0, right? So I'm going to do this. Just watch. I'm going to move that over there. 0 equals, don't write it down, because that's not good. Why is that not good? I did get it equal to 0. Now it is impossible for me to easy factor this one. Talk to a neighbor about why. What does the a value have to be? 1. And what did I make him? -1. Not good, right? Can't do that to easy factor. You can do it. You'll have to frowny face factor that. That's a lot of work. How about we do something else? Isn't the a value already 1? Could we move these two dudes over to the other side instead, right? So the x squared will be there. How do you move this positive x to the other side? Subtract x. Same thing with this positive 2. I'm going to subtract it over and keep the equal 0 there. Do you see how what you're really trying to do is keep the number in front of x squared a positive 1, so that way all you have to do is find two numbers that multiply together to be c and add together to be b, and you will understand that more after the 8-4 lesson. You know, so just keep the a 1, right? So all right, go ahead and factor that. All right, we're on to 15 now. Tell me about these two number signs. Tell your neighbor what's got to be true about those signs. They have to add together to be multiply together to be 36 and add together to be -12. Signs are either both positive, both negative, or one negative. What'd you get? Both negative, right? What numbers did you find? -6 and -6. Here's a, oops, better slow down. Are they the same? Guess what that means that is. That's a perfect square trinomial. That's a perfect square trinomial. Is the first guy a perfect square? Yes or no? Yes. X. God dang. Struggle busting here. Is the last guy a perfect square? Yes. 6 sign from the middle. If you multiply those together, you get -6x. Double that is that -12x in that case. So boom, boom, boom equals 0 in that case. Then you could square root both sides, ba-boom, ba-boom, and you get x minus 6 equals, there's no such thing as plus or minus 0, so it's just going to be 0. So what does x equal? 6. Yes, you will be able to get away with that if you easy factored it, but I would take off points because it was a perfect square trinomial, because it's x minus 6 times x minus 6 equals 0, right? And then when you use the zero product property, you get that weirdo situation. X could be 6 or 6. There's no way it could be 6 or 6 because it's just 6 in that case. When you get the same answer back twice, that means it was a perfect square trinomial. So those are just growing pains. That happens to everybody, right? That's new at this. It's like, oh, crap. Those are called growing pains. Just realize when you find two numbers and they were the same, boom, that's going to be a perfect square trinomial. Would you believe that factoring, we'll talk about that next time. All right, I just have the other three on here because of the weirdness factor of them. Is this guy ready to run? Nope. So let's make him ready to run and realize why he is kind of weird, because what would you rather do? Move all this stuff from the right to the left, or would you rather move this guy to the left? Would you rather do the blue arrows or the green arrow? The green arrow would make sense. Now here's where we could get ourselves in big trouble. Where should that plus 7t go? Don't we have to like add 7t to both sides? Where should it go? First, middle, or last? Where should it go? It needs to go in the middle. Doesn't he have a t with it? Are you with me on that? So it'll be t squared plus 7t minus 8 equals 0. The truth is, it doesn't matter where it goes as long as you know it is the b value. Isn't the b value the number in front of t all the time? The c value is the guy that has no letter next to it, and the a value is in front of the t squared. But holy crap, do your brains like it if you put it in the proper order in the first place. You know, it's like, got to find two numbers that multiply together to be this, and add together to be that. Right? So try to keep it in the proper standard form order. Got to multiply together to be -8, so one of them's negative. And I got to add together to be 7. Found my bingo with the first chance. First chance. So and then t could equal 1 or -8. Wacky, weird stuff, man. Wacky, weird stuff. So you get that one done. Get 17 ready to run, and then take a pause and look up. Do you have it in the best possible format to get him ready to run? Best possible format to get him ready to run. Because I'll show you what it should look like. Keeping the p squared having a positive 1 in front of it. P squared. And then it's a simple little game. Finding two numbers that multiply together to be a positive 14 and add together to be -9. Bada boom. And then the last one, if you can get him ready to run properly, we can just stop if you wanted to. Just get him ready to run. So for easy factoring, you're trying to keep the guy that's got the squared dude to have a positive 1 in front of it. So I'm going to move those other two dudes over there. I'm going to put the 0 right here. X squared is already over there. I need a -8x after that and a -9. Are you with me on how I determined the x squared was already a positive 1? I'm keeping that there. Right? So might as well finish it as it's easy factoring. So 1 and 9, and the 9 is negative. So 0 equals x plus 1 times x minus 9. And there we go. Hey, true or false? Easy? I hope so. Here's next time. 8-step process to factor these guys, right? 8-step process. Frowny face factoring, made up by me for a reason. It is frowny face. Do not feel overwhelmed because it's an easier process than you think. It's easier than perfect square trinomials. But if you think that every single one of these guys is easy factorable, you're going to be crazy. Tell me one more time. How do you know when to easy factor when the a value is what? 1. If I bring that worksheet back up, the a values are not 1. The GCF cannot happen. It's not a perfect square trinomial. Boo that. Not hard. It's just tedious. Cool? So we will rock it. Let me know if you have questions. Have a good one.